Hello WHS Juniors, here we go again. I got another video here for you on working with linear equations. This one is really just pertaining to graphing them, which should be relatively simplistic. You need to know the model names, or what you're seeing, what the model is, and then where to go, how to go from there to create a line. Okay, a line's the easiest thing you can graph in math. So first of all, you want to understand the requirements for graphing a line. What you need to have is you need to have 2 points of information. Okay, that's one way of getting a line. All right, if I put a point here at, say, the origin, 0, 0, and I have another point at 1, 2, and I say, can we make a line? We've been playing dot to dot since we were little guys, right? Little girls. So that would be the line. The other way you can create a line in space is only one point if you have knowledge of the slope. So, for instance, if I said, hey, I got a point for you, -2, 3, my line goes through -2, 3, and it has a slope of, say, 1/3. Well, now I'd be back here in quadrant number 2. -2, 3 is my point. My slope is saying rise 1, run 3, and that also would get me a line. Okay, so A would be 2 points, B would be 1 point plus the slope. That's the information you need to graph a line. That also is the information you need to write an equation for a line, but we're really looking today just at graphing. Okay, so the form that we see the most often in algebra is for linear equations is slope-intercept form. And basically slope-intercept form, it's y equals mx plus b. That's the form, but the b is called the y-intercept. And essentially that's kind of the starting point to a lot of functions. So I'm going to put start by that, because we're going to plot that point first, and then we're going to use the slope right here, m is the slope, to say here's where the line's going. Okay, remember, a line is just a collection of points, and if the points are increasing, the slope is going to be positive, and if the dependent value is decreasing, it's going to be negative. But we need to have a point to start off of and the slope, and we certainly can graph a line. So slope-intercept. So here I got a gal named Mrs. Johnson. Okay, she baked 40 cookies. Ben was eating an amazing 6 per hour. That's not that amazing. I think I could do better than that. Write an equation and graph. So typically, you guys, you pick a letter that makes sense for the equation. So you're talking about cookies, you could use C for that. So cookies. And I would ask, is there a starting point? What do we have? What do we have for information? We don't have 2 points. We have 1 point, we have a starting point, and it's 40 cookies. So that would be your y-intercept. From there, anytime you see per behind a number, it's indicating a rate. And slope really is just the rate of change in the dependent variable compared to the independent variable. So when you see this, this is a great indication. Hey, this is the slope. Now, is the amount of cookies going up or down? And it's down, so the slope is going to be negative. So if I write this in slope-intercept form, I would be saying down 6 cookies. Now, I'm going to use m for minutes, and it starts at 40 cookies. Okay? Now, on an assessment, they might have y equals 40 minus 6x. It's the same exact thing. It's just I'm using variables that stand for what we're talking about in the problem rather than yellow jackets and xylophones. But we have to have a starting point, and the slope tells us where it's going. From that point, the graph becomes pretty simplistic. This is going to be a first quadrant graph. You can't have a negative amount of cookies. Even a bad cookie is a cookie. I don't know what a negative cookie would actually be like, but they're all positive in my mind. You certainly can't go back in time. So your y-axis is really just your dependent variable. So I'm going to have cookies here and minutes here, and I've certainly got to be able to get to 40, so I can't go by ones here. So you got to always think about your unit spacing on a graph, what makes sense. And I might go, I've got 10 squares, I might go by 5s, and that way every 2 squares would be 10. So 10 cookies, 20 cookies, 30, 40, etc. And there we go. Now, he's eating 6 every minute. So I'm going to just keep this as going by ones. And you're not going to be asked to construct a graph, okay? I mean, these examinations are multiple choice, and they're going to have a graph for you and say which equation does it make sense with. So you should be able to flow from the equation to the graph, or from the graph to the equation. The starting point's 40 cookies. your y-intercept, your initial condition. From there it's going down 6 every minute. Okay, so if we take this and take this down, okay, that wasn't quite perfect, but there's a line. Interestingly enough, they might ask you, okay, what does that mean? Well, that would be the time when you run out of cookies. So if my math is right, about 6 2/3 minutes. But there you go. That would be your graph. Okay, so we had the y-intercept, the starting point, and the slope to get that. Okay, good. So if you see equations where y is by itself, it's instantly in slope-intercept form. Y equals slope, y-intercept, slope, intercept form. Always plot the y-intercept first. So for this particular one, the y-intercept is at 4. The slope is saying go down 2/3. And we could say, hey, that's the line for that equation. Okay? Now the second one is not in slope in for only one reason. You guys see it? Okay, the y is not by itself. So we got to undo this little thing that's combining on. So y equals negative x negative 6. I would bring notice to this. The y-intercept is at negative 6. You don't have a value listed for slope here. Remember that slope is multiplying your independent variable. So number 1 can be dummied in there. In fact, I'll write it as 1/1. So keep that in mind. If there's no number here, the number would be 1. In this case, it's negative 1/1. So it would go down 1/1, and you would get that line. Okay? The third one here is a very short little equation, and the y-intercept here is not given. The b value is a tack on. And what it's essentially saying is the starting point is at 0. It's at the origin. The slope is not written as a fraction. Think of it always as a fraction because you want a rise and a run number. So down 4/1 doesn't look like I have any parallel lines or any perpendicular lines, but I certainly have 3 lines. Okay, so get y by itself, you're going to have that slope hit model.